Throughout Lesson 9, we are going to graph some trigonometric functions. In this lesson, I'd like to first start out by graphing f of x equals sine x. Okay? Well, let's figure out how we're going to graph this function. F of x equals sine x. Well, whenever we encounter a new function, we often plot some points and then connect the dots and form a graph. So I'll do that here. I'll create a table of values. We'll put some random x values in, and we'll figure out what the corresponding y values are. Then we'll plot those points. So it's important that you're able to evaluate the sine of any given angle. Let's start with 0. Remember, the sine of 0 in the unit circle is 0. Okay? Make sure that this comes naturally for you. If not, you might want to review some of those old lectures. How about if I put a x value of pi 6? Let's plug the pi 6 in for x and see what the corresponding y value is. Sine of pi 6. Well, if we forget, we can always go back and draw our little triangle. The sine of pi 6 is opposite over hypotenuse, so that gives us a y value of 1/2. Sine of pi halves is 1. Let's just do pi at 0, and I'm just randomly choosing some values. You can choose other values if you want. 3 pi halves is -1, and 2 pi is 0. So now what I've done is I've created some points, and I'm going to plot those points on the Cartesian plane. So here's the point 0, 0. We'll plot that one. Here's the point pi 6 and 1/2, pi halves and 1, etc. So we'll take these points, and we'll just plot them, connect the dots, and see what we get. All right, so here's a coordinate system, and I'll plot those points. The first point was 0, 0, so let's go ahead and plot that. It's at the origin. Okay. The second point was pi 6 and 1/2. Let's see, that's pi, this is pi over 2. Pi 6 is somewhere in here. So there's that point. The next point was pi halves, comma 1. There's pi halves and 1. Then I chose pi 0. So there's that point. Next point I chose was 3 pi halves, -1. Certainly you can choose a lot more than this. So there's 3 pi halves, -1 down here. And then finally 2 pi and 0. So if we connect those, we should get a shape that looks something like this. And actually, this will continue and do the same thing again. Now, if we were to choose some negative values, we'd get the exact same thing over here. Okay? And there is the sine graph. Now, let's take a look at this graph. Let's see if we can figure out the domain of the sine graph. Now, notice we have the arrows. They're going to go on forever. So there's no restriction on the x values. The x values are going to go from -infinity to infinity. The range is important here. Notice, sine can get no smaller than -1. That's the smallest that sine can ever get. The biggest that sine can ever get is 1. Okay? We have these little peaks over here at 1. We have these peaks or valleys down here at -1. So the range is from -1 to 1. Okay. Now all we did was we just plotted some points. So you might want to write this down in your notes. The domain of the sine function is all real numbers. Okay? And the range is from -1 to 1. Now let's go ahead and look at a better looking graph. Mine's okay, but I went ahead and graphed it on a graphing calculator. You might want to take a look at this. And if you have a graphing calculator, certainly take a look at it. But here's the sine function. Okay. Notice sine goes through the origin. Okay. It has a peak at pi halves. There's pi. There's 3 pi halves, 2 pi. There's negative pi halves. There's negative pi. Negative 3 pi halves gets you a peak there. Negative 2 pi, etc. Okay? This is one that you have to be able to graph. In your homework, you'll have to create your own table of values and graph it yourself. But this is one that you have to memorize for this course.